Hi friends, let us today discuss about few cryptographic hash functions. As shown in the slide, this is one of the hash function widely used, but this is not much secured when compared to other hash function which we are using in real world now. However, this is the simplest one. Assume that the message is split into blocks of 16 bits each. For example, to the hash function generation system, the input is in terms of bits. Whereas we put first a 16 bit in the first row like this, and next 16 bit in the second row, and next 16 bit like this, and so on. This is how we split bit stream into the block of data. And initially we assume hash code is 0, and this is the hash code actually. How we generated this hash code is, the last bit of the hash code is simply an XORing of the LSBs of all the blocks like this. However, for example, I have written only for 3 blocks and it continues so on. If you XOR these LSBs of all the blocks, we will get a LSB of the hash code. If we XOR the first bit of all the blocks like this, we get the first bit of hash code, and this continues. For example, if we XOR the MSBs of all the blocks, we get the MSB of the hash code, and this is finally the hash code which we apply to the message and we transmit. This is about hash function 1, which is very simple one. Let us see hash function 2 now. That is also very similar to this. However, it is having bit complexity like this. Of course, we have taken a similar data where first 16 bits are stored in the first row and so on. We assume initial values of the hash codes are all 0. So what we do here is, we XOR all the bits of the hash code with the bits of this block first. Like we have colored with this light saffron color, we XOR this block of data with this hash code which is initially 0. So what we get is this is a value that we get. And next what we do is, we circularly left shift this hash code so that these 6th bit come to the 7th bit and so on, and this MSB will go to the LSB like this. And then this circularly shifted hash code should be XORed with the next block of data, which is like this. So if you XOR this second block of data with this hash code generated previously, we get fresh hash code like this. That's all. But how we got this is, previously we XOR the LSB of the second block with the LSB of the hash code, and the resultant will be overwritten here itself, and similarly so on for all the bits. And finally we get a updated hash code like this, 01140401000, and then we circularly left shift by one position like this. So after the generation of updated hash code, again this will be XORed with the third block of data like this. Again LSB with the LSB will be XORed, and it will be overwritten in the hash code, and so on it continues. So resultant updated hash code is like this. And of course again we have to do circularly by a left shifting operation, and it is like this. And this process continues for all the blocks of data. If we have a 10 block of data, it will be done 10 times, it will be XORed 10 times, and so on. And this is a final hash code generated for the message that we have taken in this example. And this hash code will be appended with the message for the transmission. However, at the reception side, depending on the different protocols, we use this hash code for the authentication of the digital signature.